Hi, Dmitry is here and welcome to my next video. Today let's talk about batteries as usually, and also about AI because it's everywhere and it can sometimes be quite interesting what it offers to us. Let's imagine that you are a maker and you want to create a sensor that will measure parameters of environment in your rooms. The sensor has to be stationary, it don't have to be wearable, so it can be a bit bulky and you not really care about dimensions and weight of this device. Let's say you're fine, you're okay with something like this. So you put it in the place which you want to monitor and that's it. Okay, so far so good. But because this sensor is wireless, you probably want to have some battery to power it because you don't want to connect it to the USB, to mains, you don't want it to stay always connected. Okay, and maybe you can try to use AI for ask it which battery should I use if I want to make this and this sensor. Well, because AI is everywhere, it's on hype, and why not ask it, yeah? So that's what I did when I developed all of the sensor. I explained which characteristics I want to get from this device. It has to be stationary, it don't has to be super small, but it should work from one replace or one recharge of the battery for maybe half of a year, maybe more. I don't want to charge it. I want to drop new battery inside and forget about it. And when I asked, I used Entropic Cloud for this, and variants that it offered was, first of all, this 2052 or a bit bigger lithium batteries. Okay. Then it offered gold standard, maybe, I don't know. This 68 if I remember correctly, so normal lithium cells, rechargeable, okay, maybe. But then I explained that, okay, dude, I want to just replace batteries once per year or twice per year. So it proposed me this. Well, okay. After some discussion, other types of lithium cells arrived in suggestions, and when I kept asking, maybe there are other batteries that I can use for this, it proposed me, well, known good type D batteries, and of course it proposed me AA batteries, but it proposed me to use 4, 2 in series, 2 in parallel, just to keep it running for longer. And that's it. Because I asked so many times, maybe you have already some understanding that I had already planned, and maybe by the shape and dimensions of this sensor you have some understanding what was planned and what was my idea. And when I asked if there are some others than this, I don't get any significant answers, any informative answers. And when I explicitly asked, okay, dude, maybe we have something like this. It's a 6-volt zinc carbon cell, or maybe we have something like this, or maybe there are other types of batteries. About this one, it said, okay, I not thought about this. Here's the characteristics, and it brought me characteristics of AA's. I mean capacity, runtime, whatever. So it just has no idea about batteries like this. And of course, This was not my initial plan. My initial plan was this one. But it never considered something like this. So, because of that, I want to say that, well, AI is a great tool, but as any tool, it has its own limitations. So be really, really careful when you ask for something, and let's imagine that you have no idea what happens here, what batteries are there. You just want to make a device, and that's it. And you will end with something like this. Is it bad? Well, maybe not. But in my opinion, we all familiar with enshittification of software. Here we can have enshittification of decisions. Will it work? Yeah, for sure it will work. But if you will optimize your hardware and software enough with this square type of batteries, maybe with alkaline versions of them, because all I have here is zinc carbon, you can get about 1 year, maybe half a year, maybe a year of runtime per one battery. And so to run this for 5 years, you maybe need 5 of batteries at all, and they are relatively cheap. And while this will technically work, I don't sure that it will not significantly degrade in 5 years, and if you will use some lithium polymers like this, maybe they will just blow up after 2 or 3 years. So will it work? Yes. Will it be cost effective? Will it be easy to work on? For sure no, because when you have this 4R12 or 4LR12, first of all you can 3D print your enclosure, and changing of battery is just as simple as this. Yeah, here I don't have contacts. I don't glue contacts in this one, so you have to put the wires on strips and put new batteries there. That's it. And actually, to make it work, you don't need any contacts inside, just 2 wires, and that's it. Even no soldering. So changing in this particular with this particular sensor, changing will take maybe 30 seconds or less, but if you glue contacts inside, you will just let all battery fall out, drop replacement in, and that's it. So I think this 3LR12 or 3R12 in the carbon variant, there are maybe best batteries for makers. Why? Because here we have voltage similar to or really close to lithium ions, and this means that you can use small boards like this one. It's a Chinese clone of Nice Nano. It made with not ESP, Nordic chip, NRF52 840, and it has charging circuits, it has some power management circuits, and you can directly connect your battery to it, and that's it. It will work, and it will work for quite long. Then when it will be time to replace it, it will be super easy. So what I want to tell is think, guys, because AI will provide you ready to use answers, and you don't have to think. You just drop your query there and you might use what it say. But our bodies are designed in use it or lose it manner. So if you will just use ready to use answers, I'm afraid that it will have consequences, quite dirty consequences. So stay curious. Thanks for watching. Have a nice day. Bye.